Now, and we have one. Now we have one point to notice here. We have here we have our x-axis here and y-axis here. Okay, we have our x-axis along C and C prime, and we have y-axis going vertically. Therefore, this is the moment, the total moment. Which axis is that total moment about? Is that the moment about x-axis or moment about y-axis? This total moment is about x-axis or y-axis. This total moment is about x-axis. So let me mark them down. This is about x. This moment is about x-axis, so we mark it as ix. But in the integral, we have y squared here. Okay. So in mechanics or in mechanical engineering, or ix is equal to y squared dA and iy is equal to x squared dA. Okay. If I ask you to determine ix, then if I ask you to determine ix, remember that is y inside. If I ask you to determine iy, then it's x inside. Okay. Remember. Now, and let's take a look of how do we work on these things. And now we have let's determine the moment of inertia of rectangle about. We will say we always put about which axis? About x prime axis here, for example. Now, because the reference is x prime axis, so this is x prime is here, and inside the integral it is y prime. The distance between here again. So, if we consider, so this is the definition. This is the definition that I will not give this in the final exam. So this one is the definition, and then we have dA equals to this is the definition, and then we go to dA. dA is this one. dA is equal to b times dy. b times dy prime here. Therefore, ix is equal to this one. So this one is equal to, before we move on, before we go forward, this one should be a definite integral. So this one is, because we have dy prime here, and then we have y prime squared here. So what should be? So we can do the integration, right? But here we should do the definite integral. We have this one to this one. Because this shape does not go from minus infinity to plus infinity. So it goes from here to there. So what should we fill in for these two blocks? So we have the origin is here. So y prime equal to 0 is here. Y prime equal to 0 is here. So where should we begin our integration and where should we end? So we should begin here and then we end here, right? So we do the integration from here to there. Therefore, we have this is y equal to minus half of x, and this is y prime equals to plus half of x. So this one is equal to so this one is equal to what? B equals to and you do the integration, right? And you will arrive in here. Now there is one thing to notice for this ix. What is the unit of this ix? Ix. Of course, it has a unit of length like meter or millimeter. So, but what is the power of the length? So, for ix, what is the power of what's the unit of ix? The length to the power of this one is the unit of length, right? This one is the unit of length, right? And then this one is the power of 3, so the power of length 3 times, and then the 4th time here. So the unit of ix is the power of the length power of 4 here. So if I ask you to calculate ix or iy to check your answer, that the first thing to check is whether your answer is the length of like meter to the power 4 or millimeter to the power 4. Before we end today's class, let's go to the next page and we take a quick look of a problem in chapter 5. Let's warm up a bit and here. This is a problem of chapter 5, not chapter 9, and we want to determine by direct integration of location of centroid of this shape. So we need to determine the location of centroid, which is x bar and y bar. And I think we had this. We have one similar question in the examination before, right? And in the examination, I only asked you to determine x bar. We did not ask you to. I did not ask you to write y bar, right? If you remember, that is the shape looks like something like. And then I asked you to determine x bar, but not y bar. Let's have a look, and we want to determine now. We want to determine both x bar and y bar. And for x bar, which is so first of all, that we determine what is k. What is k? And k is equal to c over a squared. It's okay. Next, and then we determine x bar. Here we have we determine one element here, one small element here, and so we have x bar a times is equal to integral of x dA, right? From a so 0 to a to x dA, and so it is equal to x times y dx, right, from 0 to a. It's okay. This is what we need to do in to determine x bar. And for area itself is equal to dA, and it is equal to 0 to a. Because for this small area, dA is equal to y times dx. So this is equal to y times dx. I think you can. I think you can do this, and you will get x bar is equal to 3/4 of a. The next thing is, how do we determine y bar? The next thing is, how do we determine y bar? Now, in chapter 5, we discussed one. Let's write it down. Please take your time to write it down. There are two ways to determine y bar. The first way is to cut slices like this. Cut slices in the horizontal direction, but this is very difficult because you will do something like this. But we are doing it in a different way. Let's work it out like this. And we are still looking at the vertical part. We are using one equation. That is y bar is equal to, for if we cut it into multiple simple shapes, it is equal to y a I divided by a I. Have you seen this? Have you seen this before? It is in page. It's on page It is on page, let's see, should be 54. Let me show it to you. I will come back. Page 54. Page 54 and equation 5.7. 54 or in the book 5.7. Okay. So if you have many simple shapes and we know the y bar and the y bar of the whole shape can be determined like this. It's okay. Now, if we therefore it means we have then we consider that we can write it like this. The total area is A, and we don't see for each shape we have a y bar times the A. Do we know the centroid of this line? Do we know the center of this line? Do we know the center of this line? It seems yes, because we know the height of this line, So, and it's a rectangle. So the center is half of it. So it is this one is y, and this height is half of y. This is equal to b over a squared x squared, and this one is equal to b over 2a squared x squared. It's okay. We know for each term it is for this for one slice, and we know the centroid of this line. And then we can calculate this, and it goes to here. Then we go to So from here we can get y bar is equal to 0.3.